Today's lesson is on operations of polynomials and combination of functions. First, we will add and subtract polynomials. Two terms are called like terms, or sometimes we call them similar terms. Similar or like terms if they have the same variable raised to the same exponent. Which of the following are like terms? 3x and 9x. Notice that the variable part x is the same in both, so 3x and 9x are like terms. So take a look at the variable part for the next two, 3x squared and 9x cubed. Notice that the variable part is x squared on the first one, but x cubed on the second one. They both have the variable x, but they're not raised to the same exponent. Therefore, these are not like terms. So therefore, you won't be able to add them. You can only add them if they're like terms. On the next two, we have 4x squared and 2x squared. Notice that the variable part on each of these terms is the same. X is the same and it's raised to the same exponent. So these two are like terms. On our next two, we have 5x and 3y. 5x, the variable part is x. 3y, the variable part is y. Notice that these are not the same, so these are not like terms because one's an x and one's a y. On the last two, we have 10xy squared. So xy squared is the variable part, and 4x squared y. Again, x squared y is the variable part. So be really careful on this one. Notice the x is being raised to the invisible 1 on the first one and raised to the 2 on the second one. Because the x has different exponents, these can't be like terms. Also, take a look at the y. Y is being squared on the first one, but y is being raised to the invisible 1 on the second one. This is not the same, so these are not like terms. Just be a little bit careful to notice that the square is not on the same variable, so they are not like terms. Now we're going to be adding and subtracting like terms. To add or subtract like terms, simply add the coefficients. That's the number in front. And leave the common variable part the same. When I say variable part, I'm talking about the variable and its corresponding exponent. Let's add or subtract the following. 3x squared plus 9x squared. First, let's take a look at the variable part and make sure that the variable parts are the same. We have 3x squared and 9x squared. The x squareds are the same, therefore they are like terms. And then I just take the coefficients, which is the numbers in front, 3 plus 9, and add them and get 12. And keep the variable part x squared the same. Alright, let's take a look at this. On the next one we have three terms. We have x squared y. Is there any other term that also says x squared y? Well, it looks like the third term has x squared y. The middle term has x y squared, which is not like terms, so I'm going to highlight it in a different color. So the two like terms, we have 5x squared y minus 3x squared y. When I add those together, that gets me 2 because I take the coefficients 5 minus 3. I keep the variable part the same. And the 7xy squared, that one doesn't have any like terms with it, so it's just going to come along. You cannot add these, and this is completely simplified. On our last problem, we have x squared on our first term and no other x squareds. Okay, so that's the only like term for that particular term. On the second one we have x, but I have another one that's also x. And then the last one doesn't have a variable at all, so that means it's a constant. So on this one, the x squared just comes down. He doesn't add with anything because there's no like terms with it. The two terms in the middle, negative 3x, minus 5x. I'm going to take their coefficients, negative 3 minus 5, and get negative 8. Keep the variable the same, x. And then the last term, the 15, doesn't have any like terms, so it comes down, and that's now completely simplified. Next, to add polynomials, I want you just to combine like terms. But when you subtract polynomials, I want you to distribute the negative sign to the second set of parentheses and combine like terms. So we'll have adding polynomials on the left and subtracting polynomials on the right. So let's take a look at the first polynomial. We have a trinomial plus another trinomial. So all I'm going to do here is I'm going to find like terms and just going to add them. Because this is addition, I don't have to be worried about any negative signs. So I'm looking for like terms x squared and x squared. So when I add those together, I get 7x squared. Okay, now I'm looking for another like term. We have x and x. So I add the coefficients positive 3 and negative 6 and get minus 3. Keep the variable part the same, x. And then 4 and negative 3 are both constants, so I add them and get a positive 1. And this is now completely added. Let's do another addition right below it. So I have x cubed on the first polynomial. Do I have any other x cubed? No, that's x squared, that's a constant, x squared, x. That's the only one I have for x cubed. So we're going to have 5x cubed for the first term. Now I'm looking for more like terms. I've got x squared and x squared. So I'm going to add those two together and get a negative 2x squared plus a positive. Don't forget that there's a 1 coefficient in front of any bare variable. So negative 2 plus 1 gets you a negative 1. Keep the variable part x squared the same. Now I'm looking for the next variable part. After x cubed and x squared, I'm getting x. Looks like there's only one x. 9 and 7 are both constant terms, so they don't pair up with 3x. So that means 3x is going to stay by itself. And then I have the two constant terms. So that's positive 9 and positive 7 adds together to get 16. Excellent. Now let's try some subtracting. So to subtract, you need to distribute the negative sign to the second parentheses and then combine like terms. Some students find it helpful to think of there as like a negative or a negative 1 in front here. I want you to distribute the negative sign to get rid of the parentheses there. That gets me negative x squared minus 3x. Negative 1 times a positive 3 is negative 3x. Negative 1 times a positive 7 is a negative 7. A common student mistake here is to have the negative only distribute to the first term x squared. But we need to distribute the negative truly to all terms inside the parentheses. Because when there is a negative out in front of the parentheses, that means for the whole parentheses. Notice that the first term didn't have a negative in front of it out here, so because it didn't have any negative, I'm not going to distribute any negative, I'm just going to bring it down. Now again, I'm looking for like terms. Let's look for x squared and another x squared. So when I add those together, that is going to get me, don't forget that there's a positive 1 or a negative 1 in front there. So 5x squared minus another 1x squared. Add the coefficients to get 4. Keep the x squared the same. Okay, our next one we have x. I'm looking for x, so I have two terms of x's. So now I'm going to add those two together. So I have a plus x and a negative 3x. Don't forget there's a coefficient of 1. So plus 1x minus 3x, that gets you negative 2x. And then the last terms that are left are constant terms. A positive 2 and a negative 7 gets me a negative 5. On our last problem, I'm going to distribute the negative all the way through to the entire second parentheses. So that's negative 3x squared plus 2xy minus 4y squared. If you had a negative 2xy and a positive 4y squared, you're not distributing your negative all the way through to the entire parentheses. So please be careful of that. That's a common student mistake. Okay, so let's look for like variables. So on my first term I have x squared. So I'm looking for another x squared. Once I find their like terms, then I am going to add them. Positive 5 and a positive 3, add them together, you get positive 8. Keep the x squared the same. Alright, so now I have an xy. The entire xy variable part, the x and the y part, have to stay together. So I'm looking for for an xy pair together, and I found two terms of that. So when I add them, I have a negative 1xy and a positive 2xy. When I add that together, that gives me a positive 1xy. If you choose not to write the 1 here, that's fine. Their 1 should be implied. And then the last one, I have a y squared I'm looking for. So I have two terms with y squared in it. And then I add those two together. Negative 6 y squared minus 4y squared. I take negative 6 and negative 4 and add them together to get negative 10. And then I keep the y squared the same. So that is adding and subtracting polynomials.